Hi everyone. So yesterday, the previous class we have discussed about the electric field intensity due to a non-conducting thin plate infinite sheet and also conducting sheet at a point nearby the plates, right. By using the Gauss law we find that non-conductor, for a non-conducting sheet, electric field value we got as sigma by 2 epsilon naught, for a conductor sigma by epsilon naught. Okay. So here, so what we got is this is like a non-conducting sheet. I told you that for a non-conductor, if you give the charge present inside, the charge present in the volume of the sheet. Okay. And due to this the field at some point P is nothing but sigma by 2 epsilon naught, sigma by 2 epsilon naught, where sigma is nothing but charge per unit area. So it is charge density, surface charge density, total charge by the area per unit area, right. So this is non-conducting sheet. In textbooks, every time drawing the conducting sheet is very difficult, so that is why they will just give like this. It means that it is the side view of the sheet. So when we see from this side, you can say only this, right. So this is one surface, this is one surface, and you can say in between the surfaces charge is present. So now onwards I will just draw like this. So it means that two surfaces are there, and inside the two surfaces in the material charge is present. Okay. Now this is for non-conductor. For a conductor we know that when charge is given, it stores on the surfaces. It stores on the surfaces, not in the material. Inside the material, no charge. Hence, if I take any point P inside, field will be 0. Electric field will be 0 because there is no charge present, no field. Okay na? And outside point, electric field will be just sigma by epsilon naught. Okay. So what is the difference here? Here sigma by 2 epsilon naught. Now one more sigma by 2 epsilon naught is added, so that we are getting sigma by epsilon naught. Okay na? Now in generally, while dealing with problems, they generally give you like this. Taking a conducting sheet, area of capital A, which includes only one surface, in that you can take sigma by 2 epsilon naught is the electric field. Okay na? If they are giving both surfaces, sigma by epsilon naught. If charge is accumulated on the only single surface, so due to the single surface, what is the electric field intensity? Sigma by 2 epsilon naught. Keep in mind, for a non-conducting, sigma by 2 epsilon naught. For a conductor, due to the two surfaces, sigma by epsilon naught. If on a conductor charge presents, if it is only on the one surface, sigma by 2 epsilon naught. It is very, very important. Now we will discuss the problems related to conducting and non-conducting sheets. See, two parallel non-conducting sheets are taken. Two parallel non-conducting sheet or plate, you can say, no problem, whose surface charge densities are sigma 1 and sigma 2. So I have taken two. This is one plate, this is one more, and this charge density is sigma 1, whose charge density sigma 1, and this charge density sigma 2. See, I am drawing the charge inside because it is a non-conductor. Charge presents inside also. So sigma 2. Now my question is, I have three regions. This is one region, this is the second region in between the plates, third region outside of the plates, left right side. Now my question is, what is the electric field? What is the electric field intensity? Electric field intensity in the region 1, region 2, region 3. So electric field intensity in the first region I want. You know that due to the positive charge, field lines will start. If you want to find out any field at some particular point, you assume a test charge there. Now this positive charge repel that test charge, means that field will be away from the charge. So that is why if I want to find at this point, if I want to find in this region, now due to this plate, see, this is the source and I am keeping a test charge here, it will repel it. Means due to this plate, field will be this direction. This is E due to first plate. Now due to this one, this is also positive, so that this positive will repel the test charge. So here E2 will be there. So in the first region 1, due to the two plates, the fields are in the same direction, so that simply E1 plus E2 left side. So I am keeping arrow marks left side. Okay. Now you know the formula for E. What is the E formula? E formula is for a non-conducting sigma by 2 epsilon naught. So simply sigma by 2 epsilon naught, and this is sigma 1 I have given. So sigma 1 by 2 epsilon naught plus sigma 2 by 2 epsilon naught. So taking 2 epsilon naught common, so that sigma 1 plus sigma 2. So this is the electric field in the first region. Now if you want to find out in the second region, electric field in the second region, means in between the plates. Now take a point P. Now due to this, see, this positive charge will repel it, means electric field will be like this. This is E1, E due to first plate, and due to this plate, this direction, because this is positive, repel it, E due to second. Now you can say that one is right side, one is left side. We can take right side towards the positive x-axis will be taken as a positive, this is negative. So I can say that E1 will be positive plus E2 will be negative. So that is how we can say E1 minus E2. Sir, what is E1? We know already, sigma 1 by 2 epsilon naught minus sigma 2 by 2 epsilon naught. Taking 2 epsilon naught common, so sigma 1 minus sigma 2. Here the field will be E2 will be difference of the charge densities by 2 epsilon naught. And in the E3 also, I want to find in this region. Take a point P. Here you want to find the field. Now due to this plate, field will be right side, because line starts from positive charge to the point, and here also same direction. So that E1 will be in this direction, E2 also in the same direction. So here you can say this is left, the second one is left. Now here both are in the same direction, both are in the same direction. This one is left, So here also E1 and E2 will be added. So sigma 1 by 2 epsilon naught plus sigma 2 by 2 epsilon naught. The net field, the net electric field is towards right. Okay. Then this is about non-conducting sheets. Now if I give you conducting sheet, if I give a conducting sheet, the charge will be, the electric field will be sigma by epsilon naught, no? Okay, right. Now here I am taking again non-conducting sheet only. Okay, so this is sigma of positive charge, and if it is of the same charge density sigma but of negative charge. Now what is the field in the first region, second and third? Now you know that due to this charge field will be right side, this is E due to plus, and due to this negative charge will attract the point, so that this is negative, and you know that their charge densities are same. Now E in the first region is nothing but they are opposite, so that sigma by 2 epsilon naught is taken as left side will be minus plus right side will be positive, sigma by 2 epsilon naught. So both will give you 0. Means out of the plates, take the same thing here also in the third region, where this negative charge will attract it, so field will be like this. Due to positive, field is away, this is E due to plus, both of them are again negative, say cancels each other. So that is why I can say that the electric field for equal and opposite charge densities out of the plates, outside of the plates will be 0. Now what about inside? E between second, you know that due to this one is here, due to this one is E plus, due to this one also negative will attract it, so this is also, so both are in the same direction, so that E plus plus E minus, we know that sigma by 2 epsilon naught plus sigma by 2 epsilon naught, both of them add together sigma by epsilon naught. Now what is the electric field in between the plates? Sigma by epsilon naught, out of the plates sigma by 2 epsilon naught. Okay, so we'll see some problems based on the conducting and non-conducting. So these are very important, so which will be very useful in capacitors chapter. So I am not writing the questions, it may take some time, so I am just tell you the question, so that I will draw the diagram and explain the solution for that. Okay. There is a particle of some mass is given, is kept above a large horizontal sheet. So there is a horizontal sheet like this, horizontal sheet. Above this a particle is kept whose mass is given 5 into 10 power minus 6 grams, and this charge density they have given, this is a non-conducting sheet, so charge density sigma is as 4 into 10 power minus 6 coulomb per meter square. Now what they are asking you, what charge should be given to the particle so that if it is released it will not fall down, it will not fall down. See, on this particle gravity will act, on this particle gravity acts, so that gravity will pull it down, so it has to fall down. But what they are saying now, if you give some charge to the mass so that it will be in equilibrium, means mg is acting vertically down, and to keep the particle at there must be some force required which is acting upward. There must be some force required which act upward, which is equal to weight. So who will give that force? This is a charged sheet already, means this charged body. If I give some charge plus q, if I give some plus q to the particle, automatically this positive charge will repel it. Hence we can say the gravity force which is acting down must be equal to the electric force. The gravity force is equal to electric force. Now what is the gravity force given? mg we know. What is the electric force? Force formula is EQ from the statics, electrostatics. F bar is equal to E into Q. Now, so they are asking what charge will be given, means Q they are asking, right? So mg is equal to, what is E? E means electric field. Due to what? Here sheet is kept, sheet. This sheet will give some electric field. What is I already told you what is the electric field due to the non-conducting sheet, sigma by 2 epsilon naught. So here in the place of E, we will write sigma by 2 epsilon naught into the charge. So we want the charge Q. So keep this as a subject and take all the terms other side. So it will be mg into 2 epsilon naught by, right. So this is Q and they have given mass. Take G value 9.8, 2 into epsilon naught value 8.85 into 10 power minus 12. So mass value 5 into 10 power minus 6. See, mass is given in grams, convert into kgs. 1 gram is equal to 10 power minus 3 kg, and G value take 10 and 2 into epsilon naught value 8.85 into 10 power minus 12 by sigma they have already given 4 into 10 power 6. If you do the calculations, you will get the answer. So here what is the thing? Here is a charged particle. So gravity is acting down. So to make it net force 0, so that another force required which is against the gravity, which will be given by the positive charge, this plate. See, electric field due to this one is upward. This is positive. So electric field will be upward. And that is why the charge must be plus. Why, sir? If charge is plus, electric field is upward, the force also upward. For positive charges, you know already, for positive charges, force is in the direction of electric field. If it is negative taken, then you know that for negative charges, force is opposite to the field. Means if the field is upward, negative charge will feel a force down, then it will come down. So that is why the charge must be plus. Okay na? So we will discuss one more problem. There is a long thread, silk thread, a long silk thread of a 10 centimeters long, a 10 centimeter long silk thread is fixed to a vertical wall surface of charge density sigma, other end is attached to a ball of mass m, charge some plus q. In equilibrium the thread makes 60 degrees with vertical, then find tension and charge density sigma. See, I will explain you the question. There is a vertical surface. I have given as a wall, there is a vertical surface. So I can take this as a vertical surface as a plate, and this vertical surface has a charge density. This vertical surface has a charge density sigma. Okay now to the vertical surface I attached some thread with a ball. Now so when you attach thread here and the ball here, as the ball is of charge plus q, they said, see this plus charge, and due to the positive sheet there is a repulsion, electrostatic repulsion force is there, so it will move like this. So it can go away, so that at an equilibrium this is the body, positive charge. At an equilibrium the string is making 60 degrees. So why the ball went away? Because of electric force acting. This positive will push the repulsion is there, push the ball with Fe. And you know that in this situation they are asking what is the tension and the surface charge density. So you know on this ball mass is there, so that gravity mg act downwards, and you know that in the string tension will be there away from the body. Now I can draw a y axis and x axis like this. As this is 60, this will be 60. Now I can divide t into components. One along this one as t cos 60 and one along this one as t sin 60. And they said that it is in equilibrium. You know that under equilibrium net force along x axis and y axis both are 0. So I can say that along y axis t cos 60 and weight are equal. Along x axis electric force is equal to t sin 60. So F electric force is equal to t sin 60 degrees, equation 1 along x axis. Along y axis weight is equal to t cos 60 degrees. Okay now the first one, what they are asking you? They are asking what is tension, what is sigma, what is tension and what is sigma. Now what is this electric force? You know that electric force is nothing but EQ. So Fe is equal to electric field into the charge, force is equal to EQ. Now what is this E? E is nothing but electric field due to the surface charge density. So we know that due to the non-conducting, electric field is sigma by 2 epsilon naught into the charge is Q. So this is the force Fe, which is equal to t sin 60, which is equal to t sin 60 degrees. And here they will give you the sigma values, Q values, and so that you will get the T. So here in this equation we got t sin 60, in this equation we got t cos 60. Now this is equation 3. You do one thing, equation 2 square plus equation 3 square. Now equation 2 means t cos 60 square means t square cos square 60. I am doing for right hand sides, and this will be t square sin square 60 degrees is equal to, now left hand sides mg whole square plus this one is sigma into q by 2 epsilon naught whole square. Now you know that t square take common, it will be cos square theta plus sin square theta. Anyhow, you will get 1. So, then you will get a t square formula as mg square plus sigma q by 2 epsilon naught whole square. Now, we want tension only, so that sen square this side it will be under root. So, this is how you will get tension. Here the simple thing what I did is I identified the number of forces acting on the ball, then at equilibrium I equated x components and y components. This is the way to find out tension. Okay, so after getting tension they are asking surface charge density. So, surface charge density equation you can equate, you will get. So, I am just giving you the idea, I am not giving the values here. So, I am just giving you how to do this type of problem, okay, right. So, we'll do one more thing. Now, the question what we are doing is very important. This is called the distribution of the charges. The distribution of charges on the each surface. The distribution of the charges on the each surfaces of a conducting sheets which kept parallelly. Okay, right. Now, what I will take is 2 conducting sheets I will take. 2 conducting plates A and B, 2 conducting plates A and B, given charges Q1 and Q2. So, what I am taking? I am taking a sheet like this. This is first plate A and this is one more plate B. Okay. So, 2 plates A and B. Now, for this I am giving a charge Q1 and for this I am giving a charge Q2. Now, as you know that conductor means they have 2 surfaces, charge presents only on the surfaces. So, charge will present on this surface and this surface, not inside. It is a conductor, right, as it is a conducting plates. Now, they are asking you how the charges are distributed, on the each surface of the plates. Now, what I am thinking is, okay, anyhow we have given charge Q1. Now, I will take on this surface Q charge, if Q charge is accumulated. So, on this surface how much charge is accumulated? Q charge. Now, our total charge is Q1, and what is the charge on this surface? You know that if it is like x, you know that total charge must be equal to Q1. So, x plus small q is equal to Q1. That is how we can say this x is equal to Q1 minus q, that x is equal to Q1 minus q. So, that is why if small q is on this inner surface, now this x will be Q1 minus q, and here this plate is there. Now, if it is q on the inner surface, now what must be the charge on this surface? I am taking just it as a y, okay na. So, this is for first one done, and if it is y, I am just taking. Now, I will draw a Gaussian surface like this. I am taking a closed Gaussian surface, closed Gaussian surface. Now, you know that according to Gauss law, if closed circuit is taken, closed surface is taken, Gauss law formula is flux is equal to integration of E bar dot ds is equal to 1 by epsilon naught times net charge enclosed. See here, this surface area vector is this like this, and this surface area vector also like this. So you say that if q1 is plus, this charge field will be like this only. There is no flux through these two surfaces. There is no flux through these surfaces. So 0. And this surface is inside the plate. Means when the surface is inside, you know that field is 0. Inside no field. Can I say the total E bar dot dA bar is equal to 1 by epsilon naught times net charge enclosed in this. The left hand side, the total electric field through the Gaussian surface is 0 we got. Through this anyhow 0, through this anyhow 0, no flux. But we are taking this curved surface which is inside the plate, the total flux, total electric field will be 0. To make this 0, Q enclosed by epsilon naught must be 0. Now send this epsilon naught this side, means what is the enclosed charge? For this Gaussian surface, the enclosed charge must be 0. Now already we know that for the Gaussian surface, Q and Y are the enclosed charges. Q and Y. So can I say the Q and Y are becoming 0 because the enclosure must be 0. So that is how I can say Y is equal to minus Q. Y is equal to minus Q. So hence I can say that if inner surface of first plate is given Q, automatically this Y will be minus Q. If it is a plus Q this side, if it is plus Q this side, what we are getting? The another plate inner surface must be minus Q. Okay na? Right. So we have explained with by taking Gaussian surface inside the conducting sheets. Now one more phase is left with. See, as the entire this one is Q2, second plate total charge is Q2, and now one surface is minus Q, then what will be this one? So this is minus Q plus, if it is some X I will take, so X, so minus Q and X together will be Q2. So that is why X I am getting Q2 plus Q. So that is why what is the charge on this side? Q2 plus small q. So this is how the charges are distributed for a two parallel conducting plates of charges Q1, Q2 separately given. Now what I have firstly taken? I have taken some charge small q, so that the outside will be capital Q1 minus small q. And by the explanation of the Gaussian surface method, when this plate is a small q plus charge, automatically this will be equal and opposite minus charge. And again you know the second plate charge is Q2, and due to the both sum must be Q2, so that is how minus q this side and this side Q2 plus small q. Okay. Sir, then what is small q? How to find out small q? For this now, to find small q, the value of small q, let us consider a point P inside the plate A. Now I am taking a point P which is inside the first plate. So as you know that this is small q, this is Q1 minus small q, this is minus q, this one will be Q2 plus small q, the total charge is Q2. Now when we take in point P inside, now what is the field at the point? As the point is inside the conductor, field is 0. Now can I say the field at point P must be 0? Right. Now what I will take is, at this point P, the field is because of 4 charges. See, on this surface charge is there, means it will repel it, means field will be there, and this Q will have some field, this minus Q have some field, this Q2 plus Q have some field. Sum of all the fields must be 0. Okay. Now what I will take is, if this charge have field in x direction at the P, then automatically this is small q and the whole thing will have the field left direction. That is how field due to this one will be taken. This is first surface 1, 2, 3, 4. Now what this meaning is, E due to first surface, E due to second, E due to third, E due to 4 must be 0. So at the point P, due to all the surfaces, electric field will be 0. Now what I am saying, electric field due to first surface will be right side, and all the electric fields must be left side, so that cancels each other, field will be 0. That is why I am taking this at this point P, field is this side due to this one. Now what is the field formula for a single surface? Sigma by 2 epsilon naught, or charge by 2a epsilon naught. Now we know that charge how much? Q1 minus small q by 2a epsilon naught. This is the field due to first surface, right side, and due to all the surfaces left side I am taking. So I am equating these fields. Now E due to second surface, this small q will repel it. Now what is the formula for electric field? Sigma by 2 epsilon naught. Sigma is equal to charge upon area. So what is charge? Small q by 2a epsilon naught, 2a epsilon naught left side, and this whole plate Q2 will, so I can take these two surfaces alone, like this one surface at a time, this one surface at a time I can take, or simply I am taking this entire plate. Q2 will repel the point P left side, so that electric field due to the entire plate Q2 by 2a epsilon naught. So I can cancel 2a epsilon cancels. Now I will get small q1 minus q is equal to small q plus q2. Capital Q1 minus q is equal to small q plus q2. I am sending q that side, becomes 2q, and bringing q to this side. Now I will get small q value as q1 minus q2 by 2. Now what is the charge? Small q on the plate, q1 minus q2 by 2. So that is why I am just taking now the charges here. What is this plate? Q na. So what is the q value we got? q1 minus q2 by 2. And when it is q1 minus q2 by 2, this becomes minus q. So I can say that this charge will be q2 minus q1 by 2. And what about this charge? This charge will be capital Q1 minus small q. If you take capital Q1 minus small q value in that, you can substitute, you will get this one this side as q1 plus q2 by 2, and this side also q1 plus q2 by 2. Now a technique for a conducting plates, outside charges will be average of the charges of the two plates. Outside, see this outside charges q1 plus q2 by 2, q1 plus q2 by 2, here also q1 plus q2 by 2, because this charge is q1, this charge is q2. Now what about inside? For the first inside, charges will be different, difference q1 minus q2 by 2, it will be minus of that will be q2 minus q1 by 2. So this is how to identify or distribute the charges on the surfaces. Okay na? Now we will see with one example how the charges are distributed in the plates, conducting plates. Understood? So I am just giving you there are two plates, plate 1 and plate 2. This is given charge q and it is neutral. Now I am asking you what are the distributed charges on the each surface, and we know that outer surfaces, what is the charge? Average means this is q, this is 0, means you can say that q plus 0 by 2, which is nothing but q by 2. Here also q by 2. So outside always equal, which is average of the charges. Now if it is total is q, now this side is q by 2, now automatically this side will be q by 2, because q by 2 becomes q. Now you know that due to induction or something, if this is q by 2 plus charge, then the plates facing each other, the surfaces facing each other must have opposite and equal charges. It means if this q by 2, this will be minus q by 2. If this q by 2, this will be minus q by 2. Now you can verify with. So see, this is minus q by 2, this is q by 2. Dono, like both together 0. So this is how the charges are distributed. So this is how the charges are distributed on the plates. Okay, right. Sir, if you take three plates, now I am taking 3 plates, 1, 2, 3. Now what might be the procedure? Like q 0 and here they given minus 2q. So q 0 minus 2q. Now how many surfaces here? 3 plates means 6 surfaces will be there. Now how the charges will be accumulated? See what I told you, the outside always will be sum of the charges by 2. Or what is the sum of q plus 0 minus 2q becomes q plus 0 minus 2q by 2. So q minus 2q is minus q by 2. So what is the surface? Minus q by 2, and here also minus q by 2. So when you know the outside charges, automatically it is easy to find out all the surfaces, because see it is minus q by 2, you should get total q, then what this will be? This will be, I am just taking as x. So sum of the both of them must be equal to q, means capital Q is equal to sum of the x and minus q by 2. So bring this side, it will be 3q by 2. So what is the charge here? 3q by 2 in this surface, on this surface. So it is minus q by 2, it is 3q by 2. So both together will give you q. And if it is 3q by 2, what is this charge? I told you opposite and equal, minus 3q by 2. So it is minus 3q by 2, and the total charge is 0. So that if it is minus 3q by 2, this charge will be plus 3q by 2. So together will give you 0. And when this is plus 3q by 2, it will be minus 3q by 2. And see, minus 3q by 2 minus q by 2 will become minus 2q. So this is how the charges are distributed on the conducting plates. Okay na? Right. So this is the application of a Gauss law, and we have still more applications, the last one. So what we have discussed, in the Gauss law applications, the first one is thin rod, and second one is cylinder, and third one is this non-conducting and conducting shells. The last one is volume, means taking a spheres, conducting spheres, non-conducting spheres, how you can find out the field, electric field intensities inside, outside and all of them. Okay. So this is what the class concludes.